Professor Rad here, and in today's video, we will be identifying the features of an ellipse that has been graphed for us, as well as writing an equation for the ellipse. So let's go ahead and get started. So we have our ellipse graphed on the left, and we need to figure out the foci, the vertices, the center, and then the major and minor axis, the values of A, B, and C, and then, of course, an equation for the ellipse. So I always like to start out whenever I can with the center of an ellipse. So they've graphed that for us here as this nice open circle. So the center of this ellipse is going to be the point 1, 0. Right, 1, 0. And just a reminder, when we go to write our equation later, this is going to be H and K. Next, let's look for the foci. So the foci are those little X's that have been graphed. Sometimes they are graphed for you, sometimes they are not, and you have to do a little bit more work finding them. But in this case, they've been given to us. So we've got -2, 0 and 4, 0. So -2, 0 and 4, 0. Those are our two foci. Now, because the foci have been graphed for us, that tells us where to look for the vertices. So remember, with an ellipse, you have a longer side and a shorter side. So sometimes, especially if the scale of your graphing space is different for the X and Y axis, or if the foci aren't graphed, or if the major and minor axes are really similar in length, just different by a tiny amount, it can be a little bit challenging to find those vertices. So make sure you take your time with that. If I didn't have the foci here, what I would do is I'd count up to this point here. So that would be 1, 2, 3, 4. And then I would count over to this point, 1, 2, 3, 4, 5. So since this one is longer, that's telling me this is our major axis. And so that's telling me where the vertices are. So my vertices are at -4, 0 and 6, 0. 4, 0 and 6, 0. And I might as well write it. The major axis is the x-axis. So that is a line, a horizontal line, y = 0. So that information, the major axis is where all the cool stuff is. These 2 points that are plotted here are helpful when I go to graph the ellipse, but they don't have a special name. Okay, so they're not a vertex, they're not a center or a foci. They're just helpful points to help us out. They do tell us where the minor axis is, so the center tells us that as well. So the minor axis in this case is a vertical line, so it's going to have the form x equals, and in this case, it's equaling 1. All right, so those are all the components. Now let's figure out the values for A, B, and C. So A is going to be the distance from the center to a vertex. So let's count up those lines. 1, 2, 3, 4, 5. Okay, so A is going to be 5. Now, this is where the minor axis comes into play. B is going to be the distance from the center to the minor axis, helpful points, if you will. So I think that was 4, right? 1, 2, 3, 4. Yep. So B is 4. And then C is the distance from the center to each focus. So we have 1, 2, 3. That should be 3. Now, I did mention that sometimes the foci are not graphed, and that can make them more difficult to identify. So if the foci were not graphed, basically I would have this piece would be missing and C would be missing. Everything else we could figure out. So if the foci are not graphed, remember that we have a squared is equal to b squared plus c squared. So in this case, 5 squared is equal to 4 squared plus 3 squared. So I would use that formula to help me find C. And then once I have C, I can identify where the foci are going to live by moving 3, in this case, to the left or to the right of the center. So we didn't have to do that in this example, but we will need to do it in the example in the next video. So just kind of tuck that away in the back of your brain to know that that may be a necessity when working on a question like this. All right, and then to finish up, they'd like us to write the equation of this ellipse. So to write an equation, we have to remember the shape of the equation for an ellipse. So the shape is going to be something squared, either x minus h or y minus k. So we're going to have something squared, and then it's over either a squared or b squared. So again, we're going to have something squared, excuse me there, plus the same thing equals 1. Okay? So we're either going to have x minus h and then y minus k, or reverse it. And then we'll have either a and b or b and a. So in fact, you could always put the x minus h first if you wanted to. So actually, why don't I do that? Let me write x minus h squared for the first one. I don't know where j came from. Where did j come from here? There we go. And then let's put y minus k for the second one. So remember that remembering the shape of an equation is going to help you piece together how it should go. So in video 4.1, we went through that whole reference sheet, so you can refer back to that to help you with your equations if you wish. And then for the denominator, a goes with wherever the major axis was. So our major axis was this horizontal line. So that means a is going to get associated to x, which means that b must therefore be associated to the y. So this is the formula for the equation that we're going to use. And now we just plug in the pieces of the components that we found before. So as you'll recall, I said that hk comes from the center, and we figured out a and b. So h is going to be 1, and a is 5, and k is 0, and b is 4. Beautiful. So if you wanted to, you can leave your answer like this. It tells you all of the pieces in probably the best way possible in this equation. But if it bothers you to have things that you can simplify, you can certainly simplify the little pieces. So instead of 5 squared, we could write 25. Instead of 4 squared, we could write 16. And since k was 0, we can simply write y squared instead of y minus 0 squared. So this form of the equation would also be totally acceptable. All right, so there we go. There's our graph, and we identified features. In the next video, we're going to go backwards. So we're going to start out with some features of an ellipse and then try and generate both the graph and the equation from that. So I'm looking forward to seeing you then. In the meantime, I hope you have a magnificent day, and bye for now.